Alright, welcome to section 1.1 where we're going to go over some basics of algebra. You're going to see that that's the case for most of chapter 1 and chapter 2. We're going to just review a lot of topics that you have seen in algebra 1, but it's been a couple years since you've seen it. So I just want to give you guys a little bit of a refresher. So what we're going to look at first is graphing real numbers on a number line. And then we're going to order those numbers from least to greatest. Next, we're going to look at the properties of addition and multiplication. We're going to define subtraction and division, and then we're going to end with a couple problems on unit analysis. So the unit analysis is probably where we'll spend the bulk of our time. Other than that, you'll see maybe one or two examples of each of the previous problems, because as I said, it is a review and it's kind of basic. You guys have definitely seen it. So let's first start with graphing real numbers on a number line. Okay, so let's just get a set of numbers here. I'll give you 5 different numbers. So we're going to start with 2, -3. Throw in a fraction here is 2/3, -2, and I'll give you a square root. Say the square root of 6. So our first step is to actually graph. So step 1 is to plot these points on a number line. So a number line is a horizontal line. I'm going to create a scale. Say start at -4, and I'll bring it all the way up to +4. Alright, so now that you have your number line, you're going to just go through and look at each number and place it where it belongs on that line. So 2 goes at tick 2. Make a solid dot. -3, place it right here. 2/3 is actually between 0 and 1, so it's a little more than halfway past 0, so I'm going to put a point closer to 1. Whenever you have a point that's not exactly on one of your tick marks, you should label that point. So it's very clear what that dot represents. So here this one's 2/3. Then we'll put a point at -2. And then we've got the square root of 6. Square root of 6, if we don't know, we can estimate it. It's somewhere between 2 and 3. And we can realize that because square root of 4 gives us 2. And our next perfect square, which is square root of 9, that gives us 3. So 6 is obviously between 4 and 9. So we know it's somewhere in between there. And if you actually evaluate it using a calculator, you can see rounded, it's about 2.4. So we'll actually give this little squigglies. This symbol here means roughly about or approximately. So since it's almost 2.5, I'm just going to throw a point right between 2 and 3 and label it with the square root of 6, because that's the exact value. Once you plot the points on the graph, you'll be able to basically read them from left to right, and you'll notice that they are in order from least to greatest already. So step 2, which is ordering from least to greatest, this step is quite simple. So I'm just going to go left to right, and I first see I've got a -3. Keep going, I see I have a -2. And as I keep going, my next one is 2/3. Then I see I have 2. And lastly, my square root of 6. And my numbers are now ordered from least to greatest. So that's graphing real numbers on a number line. Next, we're going to look at our properties of addition and multiplication. Okay. So this is basically going to be a chart, so you guys can build this chart with me. On the left side, we're going to have our property. Then we're going to look at the addition aspect of it, and then the multiplication aspect. We want to make sure we spell it correctly. There we go. Alright, so we're going to look at 5 different properties. The first property is going to be called the commutative property. Commutative property basically says doesn't matter what order the numbers come in. Alright, if you have two numbers, it can be A plus B, let's say, or it's going to be the same thing as B plus A. Doesn't matter which order they come in. And we can test that out if we assign the value of 5 to A and the value of 2 to B. 5 plus 2 we know is 7. And if we switch the orders, 2 plus 5, well, that's also 7. So the commutative property of addition says the order of the numbers does not matter. Multiplication, it's the exact same. Alright, it's A times B is going to be the same thing as B times A. And we can use the same values of A and B to test it here as well. So 5 times 2, well, that's 10. And that's the same exact thing as 2 times 5. 2 times 5 is also 10. Next property is the associative property. Associative property tells you it doesn't matter how you group the numbers when you have addition, all addition, you're always going to get the same value, no matter how you group your numbers. So here, let's say we've got A plus B, and we're going to throw in an extra person here, or number C. So, right, as you can see, I've got my grouping symbols and my parentheses around A and B. I can also move those and say, well, A will now be by itself, and group B and C together. And we know with our order of operations, which we will talk about later as well, that you must always work within the parentheses first. Alright, so here I'm going to have to add A and B first. Here then I'm going to have to add B and C. So we're going to keep the values of A as 5 in our test. And our value of B is still 2. We're going to assign C a value of 3. So 5 plus 2 is 7. And when I add 3 to that, we get 10. So let's hope it's the same thing on this side. So here I'm going to be 5 plus, and then grouped together is going to be 2 plus 3. Well, I got to do my grouping symbols first. So 2 plus 3 is 5. 5 plus 5 is 10. So we can see 10 does equal 10. So it doesn't matter how they're grouped. If you have all addition, you're going to get the same answer. Same thing with multiplication. So we're going to group A and B together as well. A times B, then we're going to multiply that by C. That's going to be the same as if I group B and C together. So let's say 5 times 2, and we'll multiply that by 3. It's going to be the same as 5 times the quantity 2 times 3. So we'll use a little mental math here and say, well, 5 times 2 is 10. 10 times 3 is 30. So the left side of my equation equals 30. On the right side, well, in the grouping symbols, we see 2 times 3 is 6. 6 times 5 is also 30. So that proves this property is true. So we've got commutative and associative. The third property, which we'll look at, is called the identity property. The identity property is basically saying, well, what can I do to this number so I get the same exact answer? So when you add, the only thing you can add to some value A to still end up with A is the value of 0. That is it. So our identity property is A plus 0 equals A, or 0 plus A equals A. Doesn't matter the order, as we said back up in the commutative property. So, and just saying that, well, we already know a has a value of 5. So 5 plus 0, well, of course, that's 5. Same thing, 0 plus 5 is still 5. So identity property means it keeps its identity. It never changes. Right? And the only way that's going to happen is by adding 0. Well, what about multiplication? Some people automatically jump and say, well, you multiply by 0. But when you stop and think, anything times 0 is 0. So 5 times 0, the answer is 0. So the identity will have changed. So that's not actually the identity property. So my question to you is, what can you multiply a by to still get a? And I hope you're all screaming 1, because we know everything that you multiply by 1 is the same. It's itself. So a times 1 is a. Same thing, 1 times a is a. Doesn't matter the order. And we can prove that by using 5. 5 times 1, well, that's still 5. Same thing as 1 times 5 is 5. Alright, so that's 3 of our 5 properties. The next property is called inverse. The inverse property. So the inverse property with addition is, what can I add to some value a to not end up with itself like we had in identity, but I want to end up with 0. So something I have to add to a that is going to give me 0. Well, anything that I can add to it, well, let's say 5. If I did 5 plus 1, I get 6. It's not going to work. The only thing I can add to it is its opposite, or its inverse. Alright, so the opposite of a, or negative a. Alright, so 5 plus negative 5 is 0. So when we have addition, it has to equal 0. When we have multiplication, it does not equal 0. We want to find, what can I multiply a by to not get 0, but to get 1. Right, the inverse property means we want to end up with 1. So the inverse of a here is not the opposite, but it's the reciprocal. So the reciprocal of a is 1 over a. But once we multiply by that, we have to notice the restriction here. Once we have a variable in the denominator, that variable automatically can never be 0, because we can never divide by 0. So we've got to make sure to include that restriction. So keeping the value of a 5, in order to get 1, we want to multiply by 1/5. Alright, and the last property is something that I know you guys are probably the most familiar with. It's the distributive property. And the distributive property is a little different than the previous properties because it involves addition and multiplication in one scenario. Whereas previously we had a scenario for just addition and a scenario for multiplication. This is combined all in one go. It looks kind of like associative property because of the grouping symbols. We've got a multiplied by b plus c. Right? But let's go back up. The main difference here is in the associative property, looks kind of like this. A is attached to the group b plus c through addition. In the distributive property, a is attached to the group b plus c not through addition, but through multiplication. Alright, so we've got our addition inside the grouping symbol, and attached to it is our third value, which is multiplied. So let's assign our values here. Alright, and we'll say, well, a is 5. B, what did we say B was? B is 2. And C is 3. And we're not going to evaluate it here, but what we're going to do is say, well, when I want to multiply this, I want to distribute the a to both the value of b and to the value of c. So this is equivalent to a times b plus a times c. So I can substitute those values in here and say, well, 5 times 2 and substitute that in here, and distribute this, and we'll say that's equal to 5 times 3. So we can see the distributive property here. And a little mental math will show that both sides are equal. Just like we did up here, 2 plus 3 is 6. 6 times 5 is 30. The left side of this equation is 30. On the right side, 5 times 2, well, that's 10. 5 times 3, well, that's 15. Oh, no, this isn't 6. 2 plus 3 is 5. 5 times 5 is 25, not 30. Wow. Mental error. I'm glad we caught that. So we can see this side is 25, and on the right side, 10 plus 15, also 25. So it checks out. All right. So that's our properties. We're on our way, halfway done, maybe a little bit more. Now we're going to go through our definition of subtraction and division. And this is important when we want to apply our properties, which we'll do in a minute. So, number 3 is defining subtraction and division. Okay, so 2 basic definitions which we'll just kind of put out here, and you've seen them before. So our definition of subtraction is some value a minus b is going to be the same thing as a plus negative b. And that's basically adding the opposite. Have you guys remember that? You can, if you have subtraction, you can always change subtraction to addition by adding the opposite. And we talked about the inverse earlier for our definition of multiplication, or of division, sorry. Alright, bring you back to this inverse property here, where we multiplied by the reciprocal. Well, with division, some value a divided by b is going to be the same as a times the reciprocal of b. So that's 1 over b. But remember, whenever we have some variable in the denominator, that variable has to have the restriction where it will not equal 0. So here is our definition of division. And you do that by multiplying by the reciprocal. Well, why is it important to know that? Well, when you're proving properties, which we'll do in a moment, you have to have all addition or all multiplication in order to apply these properties, such as commutative, associative, identity, and inverse. If you have division, it's not going to work. Or if you have subtraction, it's not going to work. So you want to change those to addition, such as in our definition of subtraction, and you want to change division to multiplication by applying your definition of division. So let's prove some properties here. We'll do 2 or 3 together. Alright, so we basically want to prove that these statements are true. So here's a problem. C divided by 2 times the 12 is equal to 6c. Alright, and well, let's see if this is true. What we notice here is I have multiplication here and I have division. And as I just said, we can't have division, so you got to change that to multiplication. So our first step is going to be to use the definition of division. So I'm going to rewrite the left side of this equation, and I'm going to apply the definition of division on the right side. So instead of c divided by 2, I'm going to say c times its reciprocal, 1/2. And I'm going to label what we just did. Definition of division. Alright. Well, now I can see, oh, well, half of 12 is 6, which is near what I want. But before I can multiply these together, I need to regroup them. So I'm going to group the numbers. So that's going to be 1/2 times 12. And by regrouping, if you go back and look at your chart that you just created, which property was regrouping? Oh, that was the associative property. So this is the associative property of multiplication, because that's the operation we're dealing with, is multiplication. Now, since I've got the numbers grouped together, I can evaluate them. And we know half of 12 is 6. So it's going to be c times 6. And that's basically just simplification. So we'll write simplify for our justification. Now, c times 6 isn't the same thing as 6 times c, but if you remember, the order of the numbers and letters doesn't matter when you're using multiplication. So I can just flip them around and the value is going to be the same. And by changing the order that the numbers appear, that is our commutative property. Commutative property of multiplication, because we're still using multiplication. And that property is proved. Alright, I know sometimes this is difficult for some of the students, so we're going to go through maybe 1 or 2 more of these just to give you guys a really good understanding of what you should be doing. So let's look at a second one. Let's say 6 minus 6 plus y equals y. And we can see, well, we've got subtraction and addition. And I know sometimes it's really kind of logical here. 6 minus 6 is 0. 0 plus y is y. Say, Mr. C, I understand this, but it's basic math. You are using these properties, and I really want you to think about what properties you are using. So first of all, since we have subtraction and addition, we need to make sure we have all addition. So we're going to apply our definition of subtraction this time. So I'm going to rewrite the left side, and I am going to apply my property here to the right side. So 6 minus 6 can be rewritten as 6 plus negative 6 plus y. And this is our definition of subtraction. Now, you say, oh, well, look at this. 6 and negative 6, those are opposites. So, but in order to add them together, you can try and apply the associative property, but there's really nothing grouped already, so you don't have to. If you did, it's not wrong, but it's an extra step that's not needed. You can just say, oh, 6 and negative 6, those are opposites. That's our inverse property if I add those together. So 6 plus negative 6 is 0. 0 plus y, we just applied our inverse property. If, for example, previously, this negative 6 and the y were grouped, like so, then you would have to apply your associative property first, right? Because they would have to be regrouped. But that was not part of the problem, so we'll take those away. Now, 0 plus y, well, you add 0 to anything, you're going to get the same thing. Well, the identity didn't change, so we're going to use our identity property there. 0 plus y is y. And we've just proven the next problem. So we'll do one last one. Alright, so number 3. We'll take a look at the problem. 2a plus 7 plus 3a. That's got to equal 7 plus 5a. So on the right side, what we're trying to prove is no longer just one term, we've got two terms, 7 and 5a. Well, if you notice on the left side, we have all addition already, so we don't need to apply the definition of subtraction, because we have straight addition, which is what we need. But I do see I have to combine my like terms. But in order to do that, I need to get them next to each other. Alright, and that's, if I'm going to reorder the terms, I need to apply which property? It's the commutative property, good, of addition. So I'm going to flip the 7 and the 3a. So I'm going to write 2a plus 3a plus 7. Apply the commutative property. Now, I just want to combine my like terms, 2a and 7a. And, well, actually, this is going to cause me a lot more work. I should have not flopped the 3a and the 7. It's not wrong, it just would have caused me extra steps. I want to flop, let's say, the 2a and the 7, not the 3a and the 7. So I can get the 7 all the way on the left side. So let's flop 7 and 2a and keep the 3a on the right. And when you do that, you'll see that the 7's already in the correct position. I won't need to apply the commutative property a second time. So now I just want to add 2a and 3a. And, well, that's pretty easy to do. That's my simplification here. So I'm going to simplify, and I'll get 7 plus 5a. And it's exactly as it needs to be. So that's proving properties of multiplication and addition. Alright, so we're going to get to our last bit of information here, which is the unit analysis. So that's going to be Roman numeral 5. Unit analysis. Alright, so we're going to have a few minor word problems here and just kind of use our analytical skills. So the first problem is a working problem. So let's say you work 3 hours. So you work for 3 hours at the rate of $4.60 per hour. You're really not getting paid that much. So, but maybe you're doing your friend a favor or something. So you're only charging her or him $4.60 an hour. And you work 3 hours. So the big question is, how much do you earn? A really basic question. Be like, well, you can add 463 times, or you can multiply. And we all know multiplying is quicker, so we're just going to set up our problem this way and say, alright, well, I've got 3 hours, and since we're doing unit analysis, you always want to make sure you include your units. Alright, so 3 hours, we're going to multiply that by $4.60. Whew. $4.60 an hour. So that's going to be over 1 hour. And we're going to want to multiply. So when I have 3 hours, you know that's always going to be over 1. But what you notice is that you have hours in the numerator and you have hours in the denominator. So whenever you have units in the numerator and the denominator and they're the same, those units are always going to cancel. So now we're no longer left with hours, we're just left with dollars, which is what we want. So 3 times 460 is what we're left with. And that's going to equal $13.80. Alright, let's do a second one. Alright, so similar problem. Alright, not going to be too difficult. They'll incrementally get harder though. Alright, so you travel, you go on a trip, and you travel for 5.5 hours at the rate of 60 miles per hour. So it looks like you're traveling all on the highway. Alright, the question is, if you're going at a constant rate, you're on cruise control at 60 miles an hour, how far do you go? So we want to set it up. Alright, and it's set up the exact same way as problem 1. So we've got 5.5 hours. We're going to multiply that by 60 miles over 1 hour. And when we're doing this unit analysis, if you're not setting up the problem where you have the units in the numerator and the denominator that are the same, you know you're doing something wrong. Alright, but since I see that I have something in the numerator and the denominator, they're both hours, I can take those out. Alright, now I'm just left with 5.5 times 60 miles. And, well, 5.5 times 60 is 330 miles. So that's your distance traveled. Alright, let's make things a little bit more difficult. Alright, so let's start with number 3. There's going to be a number of pieces to number 3. Alright, so the scenario is, let's still say driving. Alright, let's say you drive 50 miles per hour. And we want to find out your speed. So what is your speed? And let's first look at the scenario if speed is going to be feet per hour. So the kink here is we're no longer worried about miles. Alright, before, the hours canceled. Alright, hours canceled. Now, well, we are not necessarily worried about miles, we're worried about speed. Alright, so we got to set it up slightly differently. Alright, so we only have one unit though. What do we do? Well, let's use that unit of 50 miles. And we're going to multiply that by a conversion. Alright, because it's 50 miles per hour. Well, we want to get from miles to feet. So we need to convert, and we have to either, if you don't know it, you need to research it and know that there's 5,280 feet in 1 mile. So that's going to be our conversion there. So notice what happened. As I set this problem up, I've got miles in the numerator and the denominator, so those can cancel. So I'm left with 50 times 5,280 feet over 1 hour. So how many feet did you go? Well, 50 times 5,280 is 264,000 feet per hour. Alright, good work. Next, we're going to have to deal with 2 different conversions. Alright, we're no longer interested in feet per hour, we're interested in feet per minute. So, we still only know 50 miles per 1 hour. We need to get from miles to feet. Alright, not feet. Oh wait, yes, miles to feet, and also hours to minutes. Alright, here we still had hours, so now we're converting both units, not just the one. So we're going to set that up, and let's first convert our, doesn't matter, you can convert your feet or your hours. So let's do it this way. We're going to say, all right, if we have an hour in the denominator, we want to make sure we have an hour in the numerator. And if we want to get to minutes, how many minutes are in 1 hour? Well, that's 60. So 60 minutes. All right, and then we're going to multiply that by our feet conversion, which is 5,280 feet over 1 mile. Why do I put it over a mile? Well, because if here I've got my hours, which are canceling, I got to get rid of my miles because those aren't in the final unit. The final unit is feet per minute. So I got to get feet in the numerator. Per is the same thing as your division sign. Minute is what's in my denominator. And I've successfully converted and canceled all my units. So now it's just some basic math. So I'm left with 50 times 5,280. So that's going to be in my numerator. Feet over 60 minutes. Well, we already did this problem right here. So we know we got 264,000 feet over 60 minutes. And so when we divide 264,000 by 60, we are going to see that we'll have traveled 4,400 feet per minute. There's our answer. All right, so I'm going to do one more, but I'm going to let you guys work on it first. So I'll give you guys a little bit of time. And if I start too soon, just push pause, work it out, and then we'll check it together. So we're going to work on converting feet, all right, per second. All right, so same scenario. You drive 50 miles per hour. What's your speed in feet per second? All right, so what are you going to have to convert? All right, I'll give you a second. Okay, so push pause and work it out, and then when you're ready, push play. Alright, so we're going to basically start this problem the same way we did before, and we're going to start with our only unit given, which is 50 miles per 1 hour. And we're going to have to convert these hours into seconds. So we know 1 hour is the same thing as 60 minutes. And by doing that, our hours cancel. Now we need to get from minutes to seconds. So 1 minute is the same thing as 60 seconds. Now my minutes have canceled. So the units I have are miles per second. I need to get that miles to feet. So we're still going to multiply by 5,280 feet per 1. Oops, just 1. There's no unit on that guy. Oh no, there is a unit. Alright, because we got to get rid of the mile. Goofy me. Alright, so the mile is what we're trying to get rid of, so that cancels there. So my hours canceled. There's 60 minutes in 1 hour, then 60 seconds in 1 minute. So we went from hours to seconds, and then miles to feet. So now it's just our basic multiplication. So I see in the numerator, I've got 50. We don't need to worry about multiplying by 1, because it's going to be the same. So I've got 50 times 5,280 feet over 60 times 60 seconds. So the same calculation, 50 times 5,280, we have done. It hasn't changed, 264,000 feet. 60 times 60 is 3,600 seconds. Once we do that division, we're going to see that 3,600 goes into 264,000, 73.3 repeating feet per seconds. Or if you want to write a fraction, you can say 73 1/3 feet per seconds. That's the correct conversion. So if you guys got that, good job. If you didn't, come to class with questions and we'll work on some more problems. But that is section 1.1, and I'll see you guys next time.